Okay, back again. Is that better now?
Much better.
Okay, much better. Oh, that's good. Okay.
Yeah, sounds better.
Okay. So I'll just get my windows back open again and. Okay, so this class could be recorded and made available online. So just keep that in mind for all the classes you do at CQ Uni. That's going to be the case now. Everything's going online. So if you don't want your face to be seen, don't show your face on camera. Just mute your webcam, turn off your webcam, and if you don't want your voice to be recorded, just type in to the chat window. Okay. So this week we're doing revision and just a quick introduction. And a quick note that I'll keep making during this class is that in the prior course, GitHub was sort of optional. I encouraged students to use it, but it wasn't mandatory. In this course, GitHub is mandatory. Okay, so you need to be using GitHub from week 1. Okay, so if you're not comfortable with GitHub, don't panic. We've got some slides coming up, and I've also got introductory videos on my YouTube that you can watch to show you all you need to know. There's about 5 commands you need, and they're really easy commands, so don't panic. Okay, so we'll cover this material this week. So we'll look at the there's some PowerPoints, there's the course webpage, look at the assessment. The golden rule in this course, like the prior course, so this is a programming course, and the emphasis is on you doing lots of programming, exploring a wide range of problems, writing lots of code to ensure you understand all of the course topics and keeping up with the work each week, so don't fall behind. The study requirement for this course is about 12 hours a week. I think it's 12.5, somewhere around there. And most of that time should be spent writing code and solving problems. Okay, so I've just had a student ask me if it's okay to join a class if they're an online student. Yes, I don't mind. Please join. And especially the student that asked me, because he joins in a lot during class. So I like lots of people joining in. If people just sit there and I don't hear anything, there's no interaction, it's really hard to run a class. So more joining in is good for me. Okay. If you need help this term, there's the course forums. Okay. So there's course forums on the course webpage where you can ask questions and ask about topics, ask about the assignments, ask about anything you like. The one thing you've got to be careful of for the course forums is don't post any of your assignment work on there. So you can ask questions about the assignments, but don't post any of your work because some other student might copy and paste it and hand it in as their own, and then you might be pinged for plagiarism. Okay, so definitely ask questions, but don't share code on the forums. You can also contact the course coordinator directly, and that's Farzad. He's a great guy. He's full of enthusiasm, knows a lot about Java. He's based in Townsville. Okay, and just keep in mind there that I'm only employed 2 hours per week, so I'm just employed to teach the online course. I'm not supposed to be providing any email support or anything like that. So if you email me a quick question, I might see it, but I might see it after 3 or 4 or 5 days. But if you send me a long question, it's going to take a lot to answer. Your best bet's to contact Farzad or the course forums. If you're not sure how to keep backups, you've got to keep backups. There's a video there to show you how to keep some backups, or else just use GitHub. So there's a video I've done on GitHub, and it shows you 2 ways to use. Thank you, CC Cleaner. Shows you 2 ways to use GitHub, the command line and the web browser, and that's all you need for this course. Okay, so if you're not sure about how to use GitHub, that's the video for you to get started anyway. And then if you want to use GitHub via NetBeans or via Eclipse or whatever editor you're using, then there's further information available on the course webpage to help you with that. Okay, but in this video, I'll just go through the 5 commands or 6 commands you need to use GitHub from the command line. They're really easy commands. It's really easy to do. Okay, but it's important you get started with that this week. I've got a GitHub page here. Okay, so it's just Moose's Valley, like last term, Moose's Valley GitHub, and it's for COIT11134 for term 2, 2020 term 2. Okay, and all of the notes I work through during class, and all of the examples I do, and extra examples I do, and any problems I work through in class, they all get uploaded to my GitHub, so they'll all be here on this GitHub here. And we'll look at that in a second. In fact, we can look at that now if you like. Okay, so it's just a page on the internet, and these are all the files for the lecture examples I present each week. So week 1 is this file. Okay, and there'll be one for each week. Just extra notes and things I do when I'm chatting. I type extra examples in and add extra stuff. Down the bottom here, there's notes about what the repo will include. It's going to include everything I do in class. There's the golden rules we just talked about, and if you need help, there's what we just talked about as well. And some useful links like keeping backups and my Java videos and GitHub basics. So everything you need is all in this one repository. All the links are there. Okay. And if you want extra practice questions to work through, I've worked on it's got about 15 or 20 questions in it so far. There's a PDF I've done there, just the fun questions to solve. Well, I think they were fun anyway. So if you need extra questions and you can't find any in a textbook, you could start there in this PDF, and otherwise let the CC know or whatever, and they'll come up with more questions for you. Don't worry about that. And my Mike's Java videos, don't forget that. There's hundreds of videos there, 160 videos or something there so far. Okay, and I'll be doing more this term probably. Even though I'm just paid to run the classes, I'll probably be doing more videos, I'd say.
Do we have access to these links somewhere?
Yep. So all of these links here are in this week 1 text file, which is all there on my GitHub. So it's all in here, in that file there.
Oh yeah, sorry.
Okay. So they're probably not there now because it's just a template at the moment. But after this class finishes, I'll do an upload to GitHub, so it's just there. Okay, so if you just go to that link, and everything's there. Okay, so is that okay? So keep in mind that the golden rules are do lots of coding each week, and make sure you're okay with GitHub because you need to start using it from week 1. They're the 2 main things to take away from that. Let's have a quick look at the course webpage. At the top of the files as well, there's the course coordinator in case you need the contact details. There's my contact details as well. But keep in mind that I'm only employed 2 hours a week this term just to run the classes, just to run this one class. Okay, so I always do extra work, but yeah. Let's have a look at the course webpage. So there's the Zoom sessions you can join. Okay, so, and we're now in this one. That's me, Mike O'Malley. There's the course forums. So just use those to ask any questions you need to ask. It doesn't really matter which forum you use. Q&A or discussion are probably the 2 you'll use the most. I think the news forum is just for the course coordinator to post news. There's some of the software you need. So if you want to use NetBeans, you can use NetBeans. If you want to use TextPad, you can stay with TextPad. You do not have to use NetBeans. If you're happy with Eclipse and you want to stay with Eclipse, stay with Eclipse. Okay. So there's some MySQL stuff coming up a little bit later in the term, looks like. That's some new stuff. We haven't done that before in this course. That's good. There's some Notes about using GitHub with NetBeans. Okay, and it's really easy. You basically just right click on your project and say commit to the cloud or whatever. So it's really easy in NetBeans. There's source code if you want the textbook source code, that's there. There's a hello world using NetBeans and so on. And building a GUI with NetBeans. I'd advise you if you're using NetBeans not to use the GUI builder that's built into NetBeans because it generates horrible code. Okay, just do it from first principles, like I showed you in a prior course, and like we'll cover again in this course. We'll cover it all again. What's a label? What's a text field? We'll cover it all, and we'll build a GUI from scratch. Once you've done it once or twice, it's really easy. Okay, so there's weekly assignment submissions. This is the assessment. Weekly assignment submissions, they're worth 10%. So there's 10 submissions and they're each worth 1% each. Okay, and I think I'm pretty sure they start this week. So week 1 they start. There's your assignment 1, assignment 2, and the exam. And I think they're 20, 20, and 50. But I'll check that. Because there was some movement before term started. Okay, when you're submitting your assignments, the links will probably be in there, I'd say. Assignment submission, the links will probably be in there. If not, they'll be in the week 6 and week 11. Whenever they're due, week 6 and week 10, they'll be in those sections if they're not in these sections here. Extra material, there's some extra material there for NetBeans people if you want to use NetBeans, and so on. File IO, reading and writing a file. But we're now in week 1. So we've got the main lecture material, the addendum with the GitHub information, and there was another one as well. Oh, the bonus slides. Yeah, so that's what I've got open here. I've got these 3 files open and 3 PowerPoints. Okay, and let's just scroll down a little bit. I'm just looking to see if in week 6 there's a submission link, but there's not. So I'd say when you submit assignments, I'd say that the links will appear here. Just keep an eye. You can do a search, Control F, and search your submission. Okay. So any questions on anything so far on the course webpage or on? Is anybody going to use NetBeans? Is anybody good with NetBeans, or are people going to stay with TextPad?
I'll probably use NetBeans.
Probably, yeah, NetBeans is good. Yep.
Yeah, I've been using NetBeans.
Cool. A question here, is it okay to use Visual Studio instead of NetBeans? Yes. Yes, that's fine. Visual Studio Code, yep. That's fine. So Eclipse is fine. I'll probably do everything. Well, I might even use NetBeans if it's now the official software. TextPad seems to be. Oh, no, it's still a link. That's all right. But if you do use TextPad, when you come to connect to databases, there's a little bit more code you need to write to load in the libraries you need to connect to a database. But it's only a little bit of code, and I'll give you that code if you're working with TextPad. Okay, in NetBeans, it's just a matter of adding a library. It's really easy to connect to a database, but TextPad's a little bit more code, but I'll give you the code anyway if anyone's using TextPad. But that's all when we come to it.
I think they have TextPad hidden for us.
Oh, it is hidden, is it? Okay.
Yeah.
Okay, so I think they're encouraging NetBeans then, or Eclipse or Visual Studio Code. Okay, so the people who asked me about Visual Studio Code in the chat window, if you're finding you can't do something to do with MySQL or whatever later in the term, it might be better to change to NetBeans. So maybe if that's going to be the case, maybe change to NetBeans earlier rather than later. You can do it all from Visual Studio Code, just the commands are different and the way you lay it out's a bit different. Okay. Righto, so geez. Okay, so on with the first PowerPoints anyway. This is just a quick introduction to what the course is about. Okay, so some contact information, required textbook resources and the assessment. And probably all of this is on the course webpage as well, so it's probably already there. So I've already given you my contact information. It's on that in a text file. There it is, m.o'malley. But like I say, I'm only employed to run the lecture class this term. The course coordinator, there's their details. It's also on the course webpage. So there's the course profile there that tells you what's expected, and the study requirement is about 12.5 hours a week or 12 hours a week, somewhere in there. But we'll have a look at the course profile shortly. There's also codes of practice in there. So with your assignments, it's got to be your own work. So don't copy other people's work. Don't let other people do the work for you. All the usual stuff. Okay, that's the required textbook. So Core Java, Volume 1, Fundamentals. If you've got the 11th edition, that's great. If you've got the 10th edition, perfect. If you've got the 9th edition, that'll do fine as well. Probably even the 8th, 7th, 6th will do fine as well. It's just you might need to look up your own page numbers and chapter orders might have changed. So you might need to do a bit of shuffling there, but I'd say any version of that textbook should be fine, as long as you've got a version of that. If you don't have that textbook and you don't want to spend whatever it is, $150 or whatever it is, and you've got another Java textbook, that will probably get you through as well. There's a lot of good Java textbooks out there. One thing you do need to keep in mind though, okay. Just got a funny comment in the chat window there. So one thing you need to keep in mind though is the textbook is useful for the exam. So if you've got a PDF of a textbook, what are you going to take into the exam? Are you going to print out the PDF? What are you going to do? So just start thinking about the exam. What are you going to take into the exam if it's open book? It is open book. Okay. So you can take in any notes, anything you like. And if you're taking in a textbook, what are you going to take? Start thinking about that as well from this week. Some of the resources there, your email lists are sort of gone now. There's lectures, tutes, tutorial solutions, video lectures, all on the course webpage. And as well as that, there's, like I say, there's the extra stuff I've done in my YouTube channel where you can grab whatever you want. Assessment. So it's due week 6 online. It's due week 10, it's online 20%, and exam 60%. Although this term there is the weekly exercise as well. I've contacted Farzad and asked him to update this to add the weekly exercises in as well. And there were 10%. And the passing criteria is you must get 50% overall. So there used to be a requirement that you had to pass the exam to pass, but it's just 50% overall now. So there's a lot I could say about that, but yes. Anyway, I'll keep my mouth shut. Are there any questions on those? Anything on those slides? It's pretty well just what we covered on the course webpage, really. I'm just going through everything to make sure we follow everything that's up on the course webpage. Might have a look at the course profile next, if I can find a link to it.
if you mouse over information on the blue bar at the top, it's got the unit profile in there.
Okay, information. Oh, all right, it's up there now. It's always hidden somewhere different. And down here, you can look at it online if you like, or print it all out. I want to save or print as PDF. So there's the assessment. So the exercises are 10. Some at once been dropped, 15, 20. Like I said, there was a little bit of toing and froing on what things are worth. And the exam is actually a take-home exam this term because of COVID. So if you've got a PDF textbook, are you going to be allowed to have your computer turned on while you do the exam? I don't know. How are they going to check on you? I don't know. So maybe a PDF would be okay this term. I don't know. Here's the textbook again. Anybody got a price in a textbook?
Honestly, can't remember.
Okay, it's probably well over $100. The textbook for the prior course was $180 or something crazy.
I think it was, the ebook was about 54 or something like that.
Okay.
And the hardcover was, the hard copy, sorry, was around 90 to 100.
Okay, well, that's not too bad compared to the prior course's textbook, I guess. But like I say, if you've got an earlier version, stick with that. If you've got another Java textbook and you're happy with that, stick with that as well. Anything you need, you can look up online or whatever. There'll be something here on a course webpage as well. Just trying to save you some money if I can. In one of these sections, and it's moved, is the study commitment. I won't worry about looking for it too much, but it's in there somewhere. Somewhere in there, there's the work commitment. It's 12 hours a week anyway, or 12 and a half, something like that.
It was in the first one, if you scroll back up. Recommended student time commitment. Just there below.
Okay. Yeah, 12 and a half hours, there it is. Good, well spotted, thank you for that. Yeah, so if you're struggling or fall behind, you might need to do more than that. Yeah, but that's recommended. It's like playing a piano coding. You've got to just get lots of practice. It's the only way you can do it. Eventually, if you write enough code, it becomes second nature, and you don't even think about the code when you're coding, and you can just let it flow out of your fingertips, and you can just think about ideas, and it just transforms into code, and it's lovely. But it takes a lot of work to get there. I might do a quick intro to GitHub. There's also don't forget the video that I've done on my YouTube there to help you get started with GitHub. Shows you the 5 or 6 commands you need. Slideshow setup. It keeps wanting to show on my second monitor, and I don't want to fight with it just now. Okay, so these are Adam's slides on version control on GitHub. So what is it, why use it, and what's GitHub, and so on. So it's all about tracking changes to your work, and you can use GitHub for anything. So you can use it for, ideally it's for text files, but you can use it for anything you like. You can use it for Word documents, videos, audio, PowerPoints, graphics images, graphics libraries, whatever you want, your entire compiled code. You can upload anything you like there, okay? And it tracks changes in your work over time, in a code base or anything else over time. It's not just for programmers, it could be used by anybody. And you can inspect individual versions of the code. You can go back and look at how things have changed. You can inspect any details of when things changed, who or what changed it, what the comments they were when they checked it in. And if you want to, you can revert changes if you want to. Okay, so all of the versions of every file you check in is up there, and you can go back and look through it and see what's changed and so on. that's what version control is all about. So there's an example of part of the version control for Linux. Those various commits done, and each one of those is a record in GitHub. Not a very nice looking setup there. I'll show you something a bit nicer shortly. So there's an example of a GitHub repo for Linus Torvalds and Git. Let's look at let's go back and look at one of mine. So here's all the files that are available. And if there was fault, you can have folders as well. So there could be subfolders, and there's a zip file. That's everything at the start of term, and so on. And the README file is a special file that gets displayed down here. So, okay, but if I go back one level, so that's my commit history, and you can actually click on those, and this is like a diary for what you did that day. Okay, so these are changes I make, and I could click that, and it would show me what files I changed and what changes I made to those files. So you can just click any day you like and see what you worked on. So it's like a diary as well as a version control tool. It's absolutely brilliant. Okay, and by using GitHub, as you're working on stuff, commit your changes up into the cloud, and you'll never lose work. So if a virus attacks your computer, if ransomware attacks your computer, if your hard drive crashes, if the operating system craps out, you'll never lose work. You can just go to any other computer you like, download the repo to that local computer, and continue work as if you never had a problem. Okay, so if you get in the habit of doing commits regularly, every hour, every half hour, the most work you can ever lose is half an hour or an hour of work. Okay, and if your computer completely dies, you can move to any other computer, download the repo, and continue work within seconds. Okay, so there's really no excuses for losing work anymore. Tools like GitHub just make it so easy, let alone all the online backup tools that are available now, like OneCloud and so on. They make it so easy. So here's an example with this repo's got a lot of folders, and there's subfolders and subfolders and all that in there as well. And if you click on one of the items that you're looking at, you can see the what it looks like, and that's what I can do here as well in my GitHub. If I click there, I can see what's in there. Okay, so you can see the files as they currently exist on the GitHub. Okay. If you want to copy all these files here, you can download a zip file if you want, or you can use the GitHub commands and clone it locally. Okay, and that's what I'll show you in that getting started with GitHub. Oh, so what's that coronavirus repo? Someone just asked. Damien, yep. I'll show you that at the end of the lecture. I'll show you that one at the end of the lecture when we got time. Okay, but it's just a tool I've been working on. Okay, so, and here we've clicked on one of the files, and we've clicked on one of the commits. I think I'm squinting here, and it's very small font, but you can see what's changed. So the green stuff was what was added to the file. So it's really easy to see what's changed, what's new. If you want to go back to an old version and revert, you can revert. If you want to see what's changed and then exclude those changes, you can do that as well. A whole lot of stuff you can do. But generally, for the most of the time, you'll just be committing new changes. Reversion is something you do very rarely, only when you've deleted stuff by mistake. There's an example of reverting changes, so you can do compares and stuff and check out older versions. And you can do it all through the web interface for GitHub, although it is clunky. But if all you got is one or two repos, you can do everything through the web interface. But the command line just makes it so easy, and then you can update and keep track of multiple repositories, hundreds of repositories if you want to, just with a few commands. You can just run a command and make sure everything's up to date. So it's really good. There's some version control systems. So one of the first ones was around 72. I started using CVS, and it was also called VCS. There was another flavor called VCS. I started using it around then. And but Git and GitHub are the two big ones, and there's Subversion as well, Mercurial, other ones. Doesn't matter what you use, just make sure you're using one. But for this course, we use GitHub. And you can use it not just for this course, but you can use it for all your uni work. So push everything up to the cloud. If it's your work you're pushing up and you don't want anyone else to see it, you can create a private repository, which only you can see. Otherwise, if you want to share stuff with other people, you can make a public repository, and then other people can get access to it as well and see what you're doing. So for your assignment work, definitely make them private. Definitely make sure they're private. So Git was created by Linus. He created Linux as well and various other things. It's a distributed version control system. Projects are organized into repositories, and changes are referred to as commits. So you commit your changes to a repository, and then you can go back through previous history of those changes if you want to. So you push your changes up, and you pull the latest code down or latest files down, and you can have branches as well. So you can go, if you want to explore something, you can create a branch and work on something and just see if it's going to work. And if it doesn't work, you can terminate that branch, or if it does work, you can merge that branch back into the main code and so on. So you can do all sorts of fancy stuff as well. We don't need to worry about any of that in this course. Okay, there's a whole lot of fancy stuff you can do. So there's command line. I like using the command line, and I've also got a little tool here I'll show you a bit later as well. And there's various GUIs you can use, and there's also ID integration. So in NetBeans and Eclipse and so on, there's ID and Visual Studio Code. There's GitHub's integrated into the IDE, so you can just right-click and go add, and right-click and commit, and so on. And so if you're not happy with the command line and you're not happy with NetBeans, there's other options as well. There's various GUIs built just to allow you to work with GitHub. So the trick for you this week would be to find one way you like and stick with it. Okay. So GitHub was created in about 2008, and it's purchased by Microsoft for a lot of money in 2018. Anybody know what the price was? It was a lot of money.
No idea.
Yeah, I've got a figure on it. I've got a figure on the tip of my tongue, but I think it might be wrong. It's got to be wrong. It couldn't be $2 billion, could it? It was a lot of money anyway. Shocking amount of money. It provides free cloud-hosted Git repositories. It has a user-friendly web UI, so that's our user-friendly web UI that we're using here in GitHub. And it's the largest source hosting platform in the world. But like I say, it's just not for source code. 7.5 billion. I was thinking 2 billion. Oh my God. 7.5 billion. Okay, so if you want to get rich, folks, one thing you can do is try and think of something that nobody's done. Create a website, create a web platform, and then try and flog it to Microsoft or Google, and you'll get rich if you can do it. And or Facebook or any of those other groups with 7.5 billion in stock. That's still not bad. If I'd created GitHub, I would have taken 7.5 billion in Microsoft stock. Yeah. Okay, so how do you do it? The first thing is to create an account, and it's really easy. Just create an account like you do with Facebook or any other online platforms, and it'll send you a verification email. You go through, you click the link to verify your email, usual sort of stuff. And then you sign in, and you'll be greeted with a screen something like this, and you'll probably have nothing there at the start and nothing down here at the start and so on. And you'll go into repositories, and you'll go new, And you'll type a name here, whatever you want to type, and it'll check it's unique or not. So it puts a little tick there, and then you can type in a description, whatever you want as a description, whether you want public or private. I want to make it private. And I always initialize the README as well, just so it fills in a basic README. And then you go create, and that's it. It's really that easy. Okay, so if all your assignments, they should be private. Anything else you want to share can be public. So if I click create now, that would create a repository with that name behind the scenes, and that would be the description that appears on screen. Okay, so really easy to do. In units that link to the GitHub Classroom, there's an invite link that's in Moodle. So for all your exercises and your assignments, there's links that either have been sent out or will be sent out in Moodle to you. And then links you click on to join those repositories. Okay, so if your assignment work and things and the exercises that you submit each week, there's special links that have already been created for you to create your repositories. So they're the ones you need to use.
Each week, for the weekly code, do we need to add the new repository to NetBeans each time, or? So when you click on the repository, I'm pretty sure there'll be a skeleton. I'm not sure how they set it up yet, because as class started, they hadn't set it up yet. But I'm pretty sure there'll be a skeleton NetBeans project there. And you'll do a git pull to pull it down into NetBeans, and then you'll work on your code, and then you'll do a git push to push it back up into the cloud again with your work to submit it. I'm pretty sure that's how it worked. That's how it worked last term, and I don't think they've changed it. Okay, but it should take care of a lot of the work anyway. Whatever that link does. We can talk about that more next week if you like, but. And there's also the tute coming up with Adam. Adam's the guy that created all this stuff and set it up, so he's got the tute running later in the week. And click the new button if you want to create a new repo. If you want to, that's the command line clone you run to bring it locally. Git clone. So you run that command once, and that's the name that you gave the repo, whatever it might be. That was that KXD thing that I typed. Okay, so git clone's one command, and so where do you get that name from? You just click that little copy icon there next to that web link. Okay, so click that, drop down to a command line. I'm going to go add git bash here. In fact, I'll move it over a little bit so we can make sure everyone sees it. So I'm going to open a git command line down here. Okay, so I'm in this folder. Okay, if I'm not sure, I can go pwd to check the folder I'm in. And then I can go git clone, https, h, and so on. I could paste that link as well. So let's go up here to this link, copy, and go back down there and go shift insert to paste it. And I could clone that locally. Okay, so all of that stuff in the GitHub is now here. Here it is. That's all the stuff from the GitHub. Just clone locally from that one command. Okay. And if I open GitHub in here, I can type commands like git status to check what I'm doing, check how things are compared to the master repository. If you want to pull the latest code down, it's git pull. Everything's already up to date. If you want to add new code or new items into the repository, I go git.add with a dot, and that adds anything that's not there already. Everything's already there. If you want to commit changes, -m, and then inside quotes, you can type a comment. One work. Do that in single quotes. Git commit. Nothing to commit because I haven't changed anything. And then the final command you do is git push. Nothing to update because everything's up to date already. Okay, so git pull, git clone, git pull, git add, git commit, and git push. So 6 commands, and that does 99% of what you need to do in GitHub. And the only time you need commands different to that is when you need to go back and roll back old versions and stuff like that. It's slightly different commands. Okay, so really easy. If you're not happy with the command line, there's plenty of GUI tools you can use. And like I said as well, it's also built into NetBeans, Eclipse, Visual Studio Code, and just about every other modern IDE. Okay, so it's not hard. Thing is to become comfortable with it early, so you can forget about GitHub and just use it automatically for the rest of the term. And you'll find you use it for all your courses. Everything you do in all your courses, you'll be using it, hopefully. And, so let's just make a quick change to one of the files. And I'll put that in a file there and saving it. Let's just do the commits in it for that. So git commit. Got to add it first. So git add, you can use the arrow keys to go back through your command line. Git add, git commit, week 1 work. So it's saying one file was changed and there was 9 insertions, which is probably those 9 lines there. It's probably about 9 lines. Yep, 9 lines selected. So that's the 9 lines I inserted. And then go git push. Okay, so I've pushed those changes up into the cloud, which means when we look at that file now, there's all that junk that I just typed in. Okay, so it's really easy to use.
Just a quick question.
Great tool and really easy to use.
Just a quick question.
Yeah, sure.
In regards to committing, how is that different from just control-S-ing on your code?
Oh, okay, so you're talking about through the GUI? Yeah, so the hotkey in NetBeans might be Control-S or whatever the IDE is. It might be Control-S. Yeah.
I mean, just like an ordinary saving, like how is committing different? I'm just a little confused about that.
Okay, so saving, Control-S is saving to your local hard drive.
Yep.
Okay, and you only want to commit when you're ready to commit. So you don't want to commit every change you make. So otherwise, if you go, if you type a letter and go Control-S, you don't want every single change to go up into the cloud.
Yeah.
You want to wait till you've got maybe half an hour's of work.
Okay, gotcha.
Till you get to the next, till you get to the next checkpoint. So you've done a compile and test. Everything's working. Okay, I'll do a commit.
Okay. So you do a commit and then you push it.
Yes. Yeah. Add commit and then push.
Okay.
Yeah. Yeah. So make changes to your local copy and upload them. So everything I've showed you here with the command line, you can do through the, like I said, you can do through the IDE as well. For example, this file here, go back to that. We could go upload files, okay. We could go upload files and I could go back to that file that we changed. A bunch of new stuff. I've only got a few keys on my keyboard that I can press. We'll go Control-S and we'll drag and drop it up into the web browser. So I'm just going to juggle some windows here. We'll drag that file up there. And you could type your change in here, test, and go commit. So it's uploading the file. You could drag a whole bunch of files, not just one. You could drag a whole folder full of files, folders and folders full of files. So now it's got the commit comment test. And if we click on it, it'll have all that extra junk in it that I just typed. There it is there. Okay, so you can do it all through the web interface if you want to. It's just a little bit clunky. If you've got lots of repositories, it's just a bit clunky, a bit slower. The command line's so much faster and I think easier. Okay, but NetBeans also makes it easy. So you can use single quotes or double quotes, doesn't matter. Single quotes, double quotes. Not the smart quotes though. Those quotes there definitely won't work.
and then push. So git clone, git status, git add, git commit, git push. There's not many commands at all to worry about. So if you need help with your code, you can actually send a link for your latest commit to your lecturer or tutor, and they can view and comment on your source code. So they can actually look at what you've changed and commit and comment on your code inside GitHub. Okay. Otherwise, just zip up your files and send them. Either way works well. So commit and push frequently. I recommend at least once an hour. But do it when you get to a checkpoint. Okay, I've done a compile, I've done a test. That next bit of functionality works great. Do a commit and a push. Add, commit, push. Okay, and write meaningful messages, but keep in mind that they appear here. So don't make them too long, otherwise they truncate. So 20 characters, 30 characters, 40 characters is probably good. Anything longer just truncates, although you can still see them by clicking there and having a look. Okay, so you can see everything that's changed. Let's see, there's the old and there's the new. And if I typed in anything else, I could write that there and comment on the commit, and I could review the commit and so on. Okay, so I could type line 43 looks suspicious. Please check your semicolons or whatever. So that's what the lecturer could do when you need help. They could just comment in here and go, comment. You could come here and look and see what they've suggested. So that's a good way to work as well. Just about everything can be done in GitHub. And of course, we've only just scratched the surface there. There's a lot more you can do. You can do projects and change controls and tickets and all sorts of things. There's a whole lot of stuff you can do. You can do diagrams. There's a whole lot of stuff you can do. Dependencies. Yeah. So embrace the technology. Get into GitHub early because you need to use it from week 1. Any questions so far on GitHub or anything we've covered so far? Okay, we've got 13 people, which is great. 13 people, so 12 plus me. We might have a quick 5-minute break, and then we'll come back and look at just a quick revision of some basic stuff from the prior course. Okay, so everything we did in the prior course, we're going to cover again quickly, and then we'll add some new stuff. But we'll just do a quick revision of some of the main points this week. Okay, so we'll have a 5-minute break. Let's come back at 9:57. It's now 9:52, so we'll have a 5-minute break. Okay, all back again. Is everyone hear me okay still? Is it working?
Yep.
All good, thank you. Okay.
Good.
Okay, thank you. If you can hear some snuffling here, it's just this little. she's on the desk here next to me. So if you hear any snuffling or snorting, that's not me. It's honest.
Oh, that's so cute.
That's teeny weeny. She's very precious. The advantage of working from home. So I've just checked out the assignment GitHubs and also the week 1 tutorial, and there's nothing in them yet. There's just a README file. Okay, so there's nothing there yet. So I suspect they're going to be NetBeans projects. Okay, so with that, but like I say, I can't say for sure yet because there's nothing there. But just keep an eye on them, and if they're NetBeans projects, then it's going to definitely be best for you to stay with NetBeans. Okay, because they're already set up as NetBeans projects, but I can't say for sure yet, so I'm not sure what Adam or or fuzz at a planning. There's nothing there in the GitHub yet. Okay, so just keep an eye on things. We'll talk about it more next week, and hopefully we'll find out soon anyway when the week tutorials roll around. Okay, they should be there already. Really, they should be there already, but there's nothing there. I just did a checkout and there's nothing there. Anyway, so, but I suspect they're going to be NetBeans projects. So that means we stay with NetBeans, work with NetBeans. Otherwise, you've got to do conversions into whatever environment you're using and then convert it back into NetBeans at the end. It's very messy. Oops, just a sec. I'll just mute that for a sec. Kinker Palms, good morning. Yep, okay, I can do that. Listen, I'm just in the class right now. Can I call you back in, so it's going to be 11 o'clock. Can I call you back in an hour? Okay, so I've got your number on call already, so yes, we can do that. And what name was it? Okay, so is it just two people? Yep, so if you say that many nights, I'll do it for 95 a night. Yep. Okay, I'll see you when I get there. Yep, okay. Bye-bye. Okay, back again. Sorry about that. Oh dear. Oh no. Again, the joys of working at home, the phone's there. And when you've got an elderly mother who's a bit frail, you can't turn it off. Righto. Okay, so let's do some revision. We'll do some revision of Java classes, objects, and methods. It's just some basic stuff. Don't worry, it's not hard. It's just a few of the points from last term that we covered. So I'll talk about Java classes, objects, instance fields, instance methods, constructors, static fields, and static methods. So we did talk about static and instance last term, and we're going to talk about a lot more this term. Okay, static and instance. So only one public class is allowed inside a Java source file. So one public class per file, but you can actually have many classes in it. You can have private classes or protected classes, but only one of them can be public. Okay. And a Java file that contains the public Java class should have the same name as that class. So if the class is called if you're named like that with a lowercase f, which isn't the Java standard, your source file should be .java. Okay, but ideally you should be using a Java standard, which is uppercase F and then uppercase F. Okay, so source file and for your public class should match the public class name with a .java on the end. Every class declaration contains the keyword class, followed by the class's name. And again, it's best to use Java standard naming convention. If you're used to using other naming conventions, you need to change really to using Java. And for many, many years, I wrote code like this. Oops. With underscores between words. And it took me a lot to change to Java standard. It took me a lot because every time I went into autopilot mode, I'd start coding back with underscores between stuff again. And I'd suddenly my eyes will come back to reality, back to the current moment. And there'll be all these underscores between things. And I'll be going, oh, damn, there'll be some searching and replacing. Okay, so it's best just to get in the habit of following the Java standard if you can. The class method and variable all uses a camel case. So it's all camel case, which is that up and down, uppercase, lowercase sort of style. And no underscores between words. And class names start with uppercase F, uppercase first letter, and uppercase letter for every word. And variable names and method names start with lowercase first letter. So on. Okay, so So it's still camel case, just lowercase first letter if it's a method name or a variable name, and otherwise uppercase first letter. So no for that one. And if you're using constants, which are great, if you've got threshold values or minimums or maximums or standard messages you want to display. Careful, Teeny. She wants to stop down. If you've got constants, then they're public, final, whatever type they are. Usually they're static. Final int max temp C or something like that equals 40. So here you do use the underscores between the words, and everything's uppercase. So that would be a constant. If you've got a constant string, again, everything's uppercase and underscores between words. Okay, so stick to that and you'll be fine. There's an example of a general class in Java. You got some fields at the top, or class fields, instance fields. There might be a name and an ID and an age and a start date and whatever. It could be all that sort of data. And then there's one or more constructors, and then you've got methods down below. So that's sort of the good way to lay it out too. Have your data at the top, then your constructors, and then your other methods down below that. Okay. You can actually put these class field items or class fields in amongst your methods as well. So you could put some here and some down here. But it's best to put them at the top, I think. If you put them at, NetBeans tends to put them all at the bottom. That's fine as well. Put them at the top or the bottom, but don't spread them out amongst all your code. Makes them hard to find. Here's an example of an employee class. So just a basic employee. We've got a name, a salary, and a hire day, a string, a double, and a local date. Local date's a special type of data in Java to do with storing dates. It's a great class. Have a look at the Java help. Okay, so to use local dates in your code, you need to do an import for java.time.localDate. So that's what the import there is doing. It's just bringing in all of the time class or all of the time package. Okay. And we've got a parameterized constructor that takes in a string and double and 3 integers, and it uses the string to initialize name, the double to initialize salary, and the hire day is being constructed from the year, the month, and the day. So local date off, and that's a special method in the local date class where you can pass in 3 integers. Let's have a look at that. So local date. Whole bunch there, a whole lot of useful stuff in the local date class, but there's the auth method. So you pass in a year, a month, and a day in that order, and that's used to construct a local date object. Okay, year, month, and day. Then we've got the get methods, so get name and get salary. And what are those methods called? They've got a special name. The get method, the get name and get salary, they've got a special name.
Accessors or getters?
That's right. That's right. So there's the accessor methods, accessors or the getters. They're things like get name, salary, and so on. And usually just very simple methods to just return whatever the data is that's already stored with the class object. So just returning name or returning salary. Usually they're very simple. Occasionally they might need to do calculations, and things like get cost might involve multiplying the product price by the number of ordered and all that sort of stuff. Or getting the employee's salary might be involved a calculation as well to work out their hours and the hourly rate and whatever. Okay, but generally they're just pretty simple methods. Just return this, return that, and then we've got the set name and the set name and an array's salary. So what is set name and raise salary? There's a special name for those two methods as well. I know Wayne knows. Mutators, yeah, that's it. Thanks, Felix. They're called mutators or setters. Okay. And they're called mutators because they're changing class data. Set name actually changes the name. Okay, when we pass through a new string to set name, the class field name is actually changing to that new value. So that's why they're called mutators. They're changing class data. Okay, and doing array salary here, we're actually changing the salary, which is this salary item here. Salary equals salary plus raise. Okay, so we're actually changing the salary. So that's why that's called a mutator as well, because it's changing class data. Okay, get hire date is just returning the hire date, and so that's an accessor as well. It's just returning the value of class data. Okay, and it's not uncommon to have multiple constructors. You could have a default constructor, a parameterized constructor of one type, another parameterized constructor of another type, and it just depends on what you need to do for when you're creating class objects, and more to the point, what people using your class might know when they create class objects. So if you've got people using your class and only know the name, then you might provide a constructor that looks like this. They might provide another parameterized constructor where they can just pass in the name and set the salary to 0 because we don't know it yet, and set the hire date to null or some generic date because we don't know what that is yet either. And using that shortcut we covered in a prior course, you can save yourself a bit of code here by invoking this constructor. Okay, so instead of writing all that code there, you can just do this. It takes a year, month, and day. So we'll make it if you don't know the hire date, the default date is 1970 01 for the month and 01 for the year, for the day. Okay, so we're just passing through whatever the string is, and then a 0. So that string gets passed through there as that first parameter. 0 gets passed through as a salary, and then 1970 0101 gets passed through as the year, month, and day. So I said default date for employees starting if we don't know what it is, or whatever. Just showing you how it could work. Now, if there was validation going on here, if we had validation rules for name and salary and so on, salary can't be less than $10, and it can't be more than $50, and name cannot be blank, and it must be at least 3 characters long. We'd have to enforce those rules here, have if statements and things to enforce the rules. And we'd also have those same if statements down here in the mutator for the name, and over here in the salary. Okay, so if the salary can't be more than $50, we have to make sure the salary can't raise more than $50 here. Okay, so if there's validation rules going on, they might need to be employed here in the constructors and also in the mutator methods, wherever the data can change. Okay, and of course, then you've got the same code, the same validation code in multiple places. There's got to be a better way to do it. And yes, there is. And that might be something I can show you in this course. We'll just see how we go. Okay. A couple of simple techniques I can show you. It's just depends on how far we get. Instance fields. Instance fields and variables are declared inside a class declaration. Instance fields and variables need to be declared outside of the body of the class's method declarations. Okay, so go back a slide. These are the instance fields here. They're declared inside the class, and they're declared outside of any method bodies. They're not declared in here, they're not declared in here. They're declared up here at class level. So these items here have class scope. Any method inside the class can change them or read them or access them. Okay, they've got class scope, scope for the entire class. If we declared something like raise here inside the method, raise salary, it declares a variable called raise. That's got method scope. It's available from that line of code until that closing curly brace. Okay, so it's got method scope or block scope, if you want to say that as well. So it's available from the line of code it's declared until the closing brace of the block of code in which it's declared. These ones here, string n, double s, and so on, these have also got method scope, and they're available from that curly brace to that closing brace. Okay, so n is only available inside that method, and s is only available inside here, and so on, the other ones. We've got n here and n here, but they're separate variables. They might as well be called n1 and n2. They're completely separate. This n1 down, this string n down here has no impact or no relation at all to that string n. They're completely separate fields. Each object or instance of a class has its own copy of the class's instance variables or fields. So every time you create an employee, so we've got two constructors now. Let's create an employee using this constructor, this one here. So we're going to pass through a name. Her salary's $50. She's worth every cent, and her hire date was 2020-15. Okay, so she's hired on the 15th of February 2020, and we construct another employee called Mike. Use this other constructor for this one. So assume that's part of the class now. New employee. And they're just starting. So we don't know what their start date is yet. It's not finalized. We don't know what their salary is yet. It's still being negotiated, but we know they're going to start. So we just know their name so far. So when we pass through just a single string, this constructor will get called. And when we pass through a string and a double and 3 integers, or 4 integers, that's really 4 integers, then Java looks for a method that can take those 4 integers and comes over here and says, well, this one, it takes a double and 3 integers and a string, so that will do. Okay, because an integer can be promoted to be a double, so the 50 goes through as 50.0 into that method there. It gets converted to a double as 50.0 and uses 50.0 there. Okay, so each employee, Teeny and Mike, have got their own copy of these class fields. They've got their own name, their own salary, and their own hire day. And they're all completely separate areas of memory. So if I change Teeny's details, it doesn't affect Mike. If I change Mike's details, it doesn't affect Teeny. Completely separate areas of memory. Okay, but each employee object has got their own storage for those locations. The 3 instance fields, name, salary, and hire day in employee class will hold the data for each instance of the employee class. So like Mike's an instance and Teeny's an instance of the employee class. Instance just means an example of instance. Don't let the word instance scare you. Saying Mike's an instance of employee just means Mike's an example of an employee, or Mike's an object of type employee, or Mike's a bit of data of type employee. Okay, so that's all it means. It's not. Instance. The private string name, the private keyword means only the employee class methods can read or write to that instance field. Okay, so they're all private data items. They've all got private there, which means nothing outside the class can access them directly. The only way these fields can change is via the constructors and via the set methods, the set name and the raise salary. It's the only things that can change that data or set that data. And the only things that can access that data to read it back out into a calling method or a calling program are the accessor methods. So get naming, get hire day, and get salary are the 3 methods to get the data back out again. Okay, so the only things that can change our class data are class methods because they're private, which means if there's any rules to go along with that data, name can't be blank, it's got to be at least 3 characters, all that sort of stuff. If there's any rules, these rules need to be enforced in these methods. Okay. So the employee class is responsible for the data, so the validation should go inside this class as well, if there is any. Okay, and we'll talk about that later in the term as well. So private means it's visible only inside the class. Public means it's visible to the world. Anything can change it, anything can access it. And protected means it's visible only to the package and the subclasses of the package. Protected. So we only use private and public really in this course. Private and public. If I made this data public, so let's say I made that salary there public. So if it looked like this. Okay, so if our salary was public, that would mean I could do this. I could be outside the class creating an object, and I could say Mike.salary equals 500. Okay. How's that for a nice pay rise? Okay, I've bypassed all the rules. If there was rules there saying the salary couldn't be more than 50, I've bypassed the rules. Or if I want to, I could do this. I could add 500 onto Mike's salary 100 times if I want to. Or I could do this if I could get the current date and I could compare it to a day of the week or a year, day of the year. And I'll just write the sheet okay because I don't want to get too complicated. But if date is equal to $7.15. So if it's the 15th of July, I could add 500 onto my salary just on that day, okay, to make it really hard to track down when data is changing. Okay, so once the data is public, you can't enforce any rules. Anything, anywhere can change it. Okay, so number one rule of thumb that we're talking about now is to keep your data private. Keep your data private. Unless there is very good reason it to be public. Okay. If everything we do in this course, data should be public, data should be private. And also for your methods, keep, because they're pretty dangerous as well, keep your methods private. Unless there is okay, so in this class here, all our methods are public, and there's good reason for that. Okay, because nothing outside the class could get the name if get name wasn't public. We'd have an employee set up when we wouldn't know what their name was. Okay, we couldn't tell outside of the class. Okay, so there's good reason for these to be public. But later on, we might be creating helper methods, which shouldn't be called outside the class, and they should be private. Okay, but definitely your data, keep your data private. When there's no modifier present, when you don't say public, private, or protected, the default is that it's visible to the package. So the default is protected if you don't say what it is. Okay, so I recommend you say private or public for everything. Pick which one works best. Pick which one is applicable. Any questions so far on constructors, setters, getters, mutators, accessors, private, public? Any questions? Okay. Okay, so you default and initialization of of instance variables. So when you declare an instance field, or instance variable, you can say private double price equals 10. And that's the same as, that sets the default price for every object you create to 10. Okay, so when I create a, whatever this might be a product class or something. And that's setting the price to 10 for every object that you create. So by default, primitive types are initialized to 0 for numbers, and to false for booleans, and to null for reference types. Okay, but you can override that by saying equals 10 or equals whatever you feel like. Okay. So you can specify your own initialization as well. So you can do that at class level, up where the class data goes. Okay. So okay, so you can do it there if you want. That's quite okay. Or you can do it as a constant. So that's method 1. Let's do another method, another way to do it. And we'll do a constant. There we're using a constant to hold the default price. Okay. And then setting the price equal to default price. So we haven't even got any methods yet. Okay. And the other option is to do it in a constructor. Public product. And out of all those 3 methods, those 3 options I've just showed you, the one I like the best is this one, okay? Because you've got constants at the top containing all the magic numbers. You've got your class instance data just declared without being initialized, and then in the constructors, you're creating the values and setting the initial values. I think that's probably the neatest way to do it. That's why I like. But you can do it even more simply if you like, just by doing that. So all 3 options are valid, but I like that one. Have constants containing all the magic numbers, and just declare your instance fields without initializing them, and then initialize everything in the constructors. That way, if you follow that recipe and you've got dozens of fields, and you do some this way and some that way and some that way, if you do everything in the constructor, initialize everything in the constructor, you know it's done. Okay, rather than having to look up there and saying, oh, did I initialize that already? What's going on with that field? So whatever option you choose, just follow that for all of your, be consistent. Okay. Methods, a class normally contains 1 or more methods that manipulate the instance fields, and they belong to particular objects of the class as well. And these methods are called instance methods. So in this prior example, who can tell me the name of one of the instance methods? Which one of those methods is an instance method?
Raise salary.
Yep, raise salary is an instance method. Yep. So if we wanted to raise Mike's salary up here in this example, we could say Mike.raise salary 1.3. Raise it by 1.3%. Okay, so we're using the object dot method notation, object dot method, and we're calling the raise salary method for an object of the class or for an instance of the class. So because we're calling that method for an instance of the class, it's an instance method. Okay. Any other methods there? Okay, so we know raise salary, so we know set name is. That stands to reason get name is also an instance method, and get salary and get hire date. What's the constructor? Is that an instance method? It sort of is, isn't it? Because we're really calling it for the object here, equals new employee. Okay, we're just not calling it with a dot notation. We're calling it a different way because we're creating the object, but it really is an instance method as well. Okay. So everything appears to be instance methods. What about non-instance methods? And they're the ones that are declared with static. So if I declare a method like this, public static get max whatever. Okay, that might return public static double. That might return something. Okay, but this is a static method, so it's not an instance method. So when you call that one, you don't need a class object. You can just use the class name. For example, if that was in the employee class, you could say employee dot get whatever. So you use the class name dot method name, okay, because it's a static method. Static means it's for all class objects. Instance means it's per class object. Okay, these are static fields. Sorry, these are instance fields. So every employee gets their own name, salary, and high day. They actually get their own version of the methods as well. So the get name returns that employee's name, for example, Teeny's name or Mike's name. Okay, but when they're static, they're like shared methods amongst all class objects, or shared data amongst all class objects. If you're talking about static data, so up here I had some static data. I think it was yes, private static double. Okay, so that's made that static data, which means it's at class level, not at the object level. Okay, and the default of making it static data is that you're not storing multiple copies of that value 10.0 every time you create a class object. You're just storing it once for all class objects. Anyway, we'll talk about static and instance a lot more as we go. Don't worry, I'm going to be talking about that a lot as we go on, probably every week. So don't worry if you don't quite get it. Well, in a few weeks you'll be fine. Don't worry. Private, public, double. Yep, methods. In employee class, instance methods set names, implementation codes, assign values to the end parameter to the instance variable name. So instance methods get access to the instance data. Okay, so down here, get name, that's an instance method. So you get access to the instance data. So if we're talking about calling this get name method for Teeny, we will be returning Teeny's name. Okay. If we're calling this method for Mike, and we go Mike.getSalary, we're returning Mike's salary. So these are all instance methods. So returning instance data or using instance data. And that's all instance data as well. Well, that is salary, and that is. In the employee class, instance method getSalary returns a particular employee's object salary to the calling method or whatever it's calling from. Okay. Many objects of a class, each with its own copies of the instance variables, may exist at the same time. And we did that with Mike and Teeny up here. We had Mike and Teeny. So you can have as many employees as you like until you run out of memory on the computer or whatever. Exist at the same time. Static methods in a class can access static fields and other static methods. Static methods do not have this parameter or this object or this whatever it is. Okay, so down, let's just talk about that a little bit more. So when you create these methods like that, let's just have a look at Ray's salary quickly. Down here. Void set name string n. Okay, so in the set name method we had this sort of thing. We had a string called n being passed through, and we said name is equal to n. Okay, and that was really clear because name's our class instance field, and n is this local field. But they could actually be the same variable name. Okay, in which case is this name that one, or is it the one at class level? And is that name there? Is that one, or is it the one at class level? How do you tell them apart? And that's where the this parameter comes in. So you put a this in front, this dot, that means the current class name. And the one without the this in front means the local variable called name, which is that one. Okay, so this dot just means for the current object, get their name. Okay, get their name field. Okay, so that's where the this comes in. So static methods like this chap do not have a this. So you can't say return salary. That was part of the employee class. That would be wrong. You couldn't say return this dot salary because that's the same thing. That would still be wrong. You cannot access any class instance data from a static method because they're methods that are up at class level. They're shared amongst all class objects. Okay. So only the instance methods can access instance data. In this case, we're talking about salary, name, high date. Static data and methods. Okay, but if this confuses you, don't worry. We're going to be talking about that a lot as we go, and I'll have some diagrams for you a little bit later on as well. That'll explain everything. So static methods don't have a this parameter because they're shared amongst all class objects. They're not per class object. A constructor has the same name as a class. It can have more. You can have more than one constructor. A constructor can take 0, 1 or more parameters. What's the special name for a constructor that takes no parameters? There's a special name.
Default.
The default constructor, that's right. Yep. A constructor has no return value, and a constructor is always called with a new operator. That's how you invoke constructors with a new operator. Okay, so they've got the same name as a class. They've got to be public. You can have private constructors, but that means they can't be called from outside of the class. So if you're doing something very, very tricky or something where you don't want certain constructors to be called outside the class, you can make them private, but then nothing outside the class can call them. They can only the public constructors can be used outside of the class. Okay, so generally for everything we do, it'll be public followed by the class name. Followed by round brackets, and inside there might be one or more parameters or no parameters, and we might have many constructors. And you provide constructors for flexibility. If people know certain bits of data when they're creating class objects, you provide a constructor so they can create those class objects without guessing the other values. And you can fill the details in later. The default constructor, if a class does not define any constructors at all, Java actually provides a default one for us. So if you've got a class without any constructors, Java will provide a default one for you. And it will set all numbers to 0, all booleans to false, and all reference variables, strings, dates, so on. It'll set those to null. Okay, so if you don't have any constructors in your class, Java still does take care of you by providing a default constructor. Behind the scenes, it doesn't insert it into your code, it puts it into the bytecode that's generated, and that will automatically initialize numbers to 0, booleans to false, and reference types to null. Okay. If you create a constructor for a class, any sort of constructor at all, then Java no longer provides the default constructor for you. So if you provide a constructor that looks like this, if your class has got one constructor and it's like this, okay, and you try and so that's your class now, and you've got a constructor there that does something with that data. If you try and create a class object like this, that going to be okay? We know this one will be. Let's do this one first. That one's fine because we're calling that constructor. But here we're trying to invoke the default constructor. And according to that prior slide, if you declare a constructor for a class, then the compiler will not create a default constructor. So we've declared a constructor. So this one doesn't exist. There's no default constructor anymore. Java doesn't create. As soon as you create a constructor, Java says, that's it, you're on your own. You're creating the constructors from now on. Okay, so to make this work, you'd have to provide another constructor that looked like this. Something with no, okay, to make it work. And until you did that, until you provided that extra constructor, that would be an error. So you add a default constructor. Okay, so there's various rules you got to keep in mind as you're writing in Java, and that's one of them you need to keep in mind. So in other words, as soon as you start providing constructors for your class, provide a default one, provide one or more parameterized ones. It's just like a recipe will do. There's an employee tester, so a little test harness to go along with our class. So we've got an array of employees here. Employee staff equals new employee, staff 0 equals new employee, Carl Cracker. Passing through their salary, there's hire date year, hire date month, and hire date day. So we're creating 3 employees. We're storing them in an array of size 3. And then we're looping through employees with a special version of the for loop. That's the for each loop or a compact for loop. For each employee in the staff array, we're going to raise their salary, e.raise salary by 5%. Okay. And then we're using a compact for loop again to display each employee. System.println. So for each employee E in the staff array, that's our staff array there, we're going to get their name and then get their salary and then get their hire day. Okay, so something we'll be doing a lot of, we'll be creating arrays of objects and array lists of objects and also other things as well, like linked lists later on. Okay, so we'll be creating lots of arrays or array structures of objects as we go. And that's just a simple array. And you did exactly this sort of thing in your assignment too for the prior course. And lots of tube questions too, hopefully. Okay, but just creating an array, declare an array of pigeonholes, a one-dimensional array, and in each pigeonhole we're putting an employee. Carl Cracker, Harry Hacker, Tony Tester, and then we're displaying them all, or raising the salary and then displaying them all here. Okay, so hopefully that's not strange to you. Hopefully you've seen that sort of code before, because we certainly did it many times in a prior course. So instance of employees created by the following code equals new employees. That's calling the constructor, the parameterized constructor that takes the 5 fields, string, double, and 3 ints. And that's new instance fields are set. So name set to Carl Cracker, salary 75,000, and hire day set to a date version of that, 15th of December, 87. You can add more than one constructor in a class, and we'll be doing that often as well. So here we've got a default constructor, a parameterized constructor that takes a string and a double, another parameterized constructor that takes just a double, a default constructor over here, and so on, the other methods in the class. So here we've got 3 constructors, 2 parameterized and a default. Okay. And here they're using a shortcut that I've showed you in a prior course and we talked about earlier as well. So here we're invoking the other constructor. So we're saying whatever the double is passed in, we're passing that across to the other constructor and also providing a blank name. So that's going to call a constructor that takes a string and a double, which is this one. So it's going to run that code there. So name will be blank and salary will be whatever the value of S is that's passed through. Here the default constructor isn't doing anything. It's not calling anything. It's just got a couple of comments. So name will be set to space or blank because it's initialized here, and salary will be set to 0 because that's what Java does by default. Okay. Are there any questions on those? Okay, we'll push on because we're running out of time. I've waffled too much. A static method can manipulate static variables in the same class directly. So static methods work on static data. Okay, to access the class's instance variables and instance methods, a static method must use a reference to an object. So it must either create its own object or it must be passed a reference to the object. So without those, either of those two things, a static method cannot work with any objects of the class. Okay, so and we'll talk about this more next week as well and in the future. A static method can call other static methods of the same class directly using the method name by itself. And instance methods can use all the fields that are static and all the methods of the class. So instance methods can use static data, and static methods just call them directly, access them directly. But static methods cannot use instance methods directly or access any instance data unless they've got a reference to the instance object, or they create their own reference to the object. Okay, and we'll be looking more at all this sort of stuff as the term goes on. A static field or variable, a static field called a static variable is shared by all objects of the class. It's like a global bit of data that all class objects share. The declaration of a static variable begins with the keyword static or public or private or whatever as well. So public, static, final, whatever. The following program uses a static field and a static method. So I've got an example coming up. There's our static field. So private static int next ID. It's got a value of 1. Because it's static data, all class objects are sharing this field. Okay, so if one class object changes it, the other class objects get that updated value as well because they're all sharing the same field. Okay, they've all got their own name, salary, and ID, but they're all sharing this piece of data. This is like global data shared amongst all class objects. Down here, get next ID returns the next ID. And when we set an object's ID, we set the ID equal to the next ID and add 1 to the next ID. Okay, so when set ID is called, we're using that value of next ID, setting ID equal to the next ID, ID equals next ID, and then we're adding 1 to next ID. Okay, so every time you call set ID for an object, you'll be setting its ID and incrementing this piece of global data that's available to all class objects of type employee. Okay, so if I've got Mike and Teeny and I call set ID for Mike, Mike's ID will be set to the current value, which is 1, and then next ID will be incremented to 2. And then if I call set ID for Teeny, ID will be 2, because next ID's now got the value of 2, and then next ID will be incremented to 3. Okay, so it's global data for all class objects. Okay, so up here in our tester, we create our 3 employees. We call e.setID for each employee, and then we get their name, their ID, and their salary. And then we're calling get next ID again at the end, and the next available ID is whatever. Okay, so e.setID, Tom should be 1, and then next ID is incremented to 2. And then we call setID for Dick, so his ID will be 2, and the next ID is incremented to 3 behind the scenes. And then we call it for Harry, so e.setID for Harry, so Harry's ID will be 3, and then next ID behind the scenes is incremented to 4. So when we call get next ID down here, that just returns the value of next ID. So we should see the value 4. The next available ID is 4, should be on screen. Okay, and that's a really common use of static data. So automatically allocating IDs is a great use of static data. If you've got maximums and minimums, and that's a great idea. That's a great use of static constants. But this isn't a constant. There's no final there. Okay. Okay, so by making that static, we're sharing it amongst all class objects. So when one adds 1 to it, all the other class objects have that same data, that same value. So instead of calling setID, we could have done it here as well. We could have just called it in one of the constructors, like there. We could have called it up here and just said next ID plus plus and ID equals the current value of next ID. We could have done it down in here as well in the constructor. They chose to do it differently. I don't know why. It's just the example. So setID needs access to class data because it's using the employee's ID. So it's got to be a instance method. So there's no static there. But getNextID doesn't need to access any instance data at all. So that could be an instance method or a static method. Okay, and we can save a little bit of memory and a little bit of machine resources by making it a static method. It's not duplicated for every class object then, it's just held once. Okay, so if you can make your method static, if all they're doing is working on static data or data that's hard-coded inside the method here, then make them static. Just saves you a little bit of memory. And later on, when you're creating millions of objects, you can save those millions of bytes. Okay, we'll talk about that a lot more as we go. 22. So create a UML diagram for the fixed account class. A fixed account has the following attributes. Account number is numeric, period in use, initial amount is numeric. So we've got 3 instance fields there. Okay. Include a two-string method with the correct access specified to display the details of a fixed account. So the activity number 1 there is create a UML class diagram. So not a UML activity diagram, not a UML whatever diagram, it's a UML class diagram. Okay, so let's do that. We can do that together. So the first thing you do is the class name, which is fixed account. And I'm just going to do it in, you can do it in fancy diagramming tools if you want. I'm just going to do it here in TextPad. Okay, so the class name goes first, fixed account. Okay, so that's the start of our diagram. That's our diagram there. Okay, then you put your instance fields or static fields as well if you want. So we've only got 3 instance fields for this one. So account number. And all we're told is it's numeric. We're not told whether it's an int or a double or whatever. So all we can say is that it's numeric. I don't know what it is. It's probably an integer, but all the example says it's numeric. Okay. So period in years. And so on for the other one. I'll let you fill in the other one. Okay. And what sort of access modifiers should they have? So should that data be private or public? And the golden rule is, don't forget, keep your data private, unless there's good reason for it to be public. So it should be private. And in UML diagrams, you should signify that with a minus. Minus means private. And I usually put a little key down the bottom of my diagrams, key, minus equals private, plus. Put a little key down the bottom, then no one can get confused. So do fill in the third one there. You can do that on your own. And the only method we got is toString. And to be able to call that outside of the class, that should be public. So that should have a plus, toString. And it's public. And it returns a string. Okay, so that's our UML diagram. We've got 1 method and 3 data items and an account name. So that's where your data goes, and that's where your methods go down here. So if we had constructors and setters and mutators, they'd all be listed down here as well. Okay, so that's our basic UML diagram. It's not a bad idea to do when you're creating a class to put that sort of stuff at the top of your class as a comment. So that if you need to give the class to somebody, you can just compile it and just give them the UML diagram. So they don't need to, unless they need to see your code or access your code, you can just give them the compiled code, give them the UML diagram, and they'll know how to how to work with your classes. They know what constructors are available, they know what methods are available. Okay, so we're rushing a bit, but we're running out of time. Activity 2, implement the UML diagram, create an activity 1. So now it comes time to create the class. So public, fixed account. So we have private. I'm going to make a decision and call those integers for those first two, account number and account years. Account balance probably should be, initial amount probably should be a double. Okay, but I'm going to make that first one an integer. So the only method we've got is a toString. That's the only method we've got. So that's public string toString. It's going to return a string representation of our data. So account number. Let you fill in the rest. And so there's 2 other data items to fill in there. So that's the sort of thing you need to do. It's only a very simple basic class, unless there's anything more added here. Oh, so here we go. It says a no argument constructor, a parameterized constructor taking all 3 arguments, a parameterized constructor taking only the account number, accessor and mutator methods, and validation checks for all the set methods, and should be also the constructors. Add to the fixed account class a new field, number of accounts, to store the number of accounts created. Okay, so we use the static field before to control allocating the ID. Here it's asking us to use a static field to allocate, to add 1 to it every time we create an account. So every time a constructor is called, we want to add 1 to that number of accounts. And add a get method to get the value of that so we can see how many accounts have been created back in the main program. Okay, so you're going to want fixed account. That's the no argument constructor. The default constructor is a no argument constructor. And then one taking all 3 arguments, which is the account number, and so on for the other 2. And then say this dot account number equals account number. So on. Okay, and then fixed account could just call the other constructor. This 0, 0, 0. So we're passing through the 3 numbers this one needs. So I'm leaving the dots there for you guys to fill in at your own because we're running out of time. And then we want the static field. So that's going to go up here. So private static int. So there's our static field at the top here. So every time we call a constructor, we've got to add 1 to that number of accounts. So we could do it here as well, and down here. Why do it in 2 places? This is calling the other constructor anyway. That's already been done. Okay, then we're going to have to add public int get account number. So we're returning account number, and then we need a setter for account number, public void set account number, int account number. Doing the setters, so we do a mutator for each field, a setter for an accessor for each field, a mutator for each field. And it also says to put in the validation checks. It doesn't say what validation checks to do, but I would assume it would be account number is less than 0. So you display an error here. Write the code for that. Otherwise, if the account number is not less than 0, you could set the class field to the account number passed in. Something like that. And then you need a get number of accounts. So you need a method for that as well. And that could be an instance method, because all the instance objects get access to that field as well. That would work fine. It's an instance, it's a static field, but that's fine. Instance objects still get access to it. So that would be an instance method, but we can also save a little bit of memory by making that static. That is good practice. If all you're accessing down here is static data, make it a static method. Just saves you a little bit of memory. Becomes important when you're dealing with billions of objects or millions of objects, especially, or in shared environments. Okay, so have a look at that anyway, and see the other two. There's another constructor to do. There's 2 more accessor methods to do. There's 2 more. There's 2 more mutator methods to do, and there might be other bits and pieces as well. But I'll let you guys finish it off. If you've got any questions, come along in the tute and ask, or ask in next week's class, and we'll look at that. I think we're running out of time. I don't want to keep anyone. People are probably running to classes. The number is, we're down to 10 now, so we've lost 3 people. I might leave this to next week. We didn't get to it. I'm sorry. We could cover it quickly, I suppose. It'll be on the video. We'll do it next week as well. Examine the following. If you've got to go, you can go, but I'll just wrap this up, and we'll cover it also next week. But I'll do it now for the video as well. Int num1 equals 10, num2 equals 15, num1 equals num2. So here we're changing the value of primitive types. So num1 and num2 are separate areas of memory. Okay. Here we're creating 2 employees, E1 and E2. Okay. And here we're saying E1 equals E2. So what happens? So E1 contains the area of memory where John is. E2 points to the area of memory where Mary is. When we say E1 equals E2, we're saying E1's memory address is equal to E2's memory address. So we're copying memory addresses here. So now E1 and E2 both refer to Mary. No one's referring to John anymore. John's on his own, but E1 and E2 are both referring to Mary. So if E1 set name for Mary, that'll affect E2 as well, because E2 is also referring to Mary. So you've got to be very careful with this sort of thing in Java with reference types, because you're copying the memory addresses, not the data. If you want to copy the data, you need to do a clone or some sort of method like a clone. Okay, and then looking at that here, before returning a mutable object, clone it first. So if you just return the reference, then you're returning a memory address, so anything can change it. Okay. So here we're doing a highday.clone, and we're returning a date version of that, just keeping Java happy. Highday.clone, and we're converting it to a date because we're returning a date here. So that was a local date. We're doing a clone of it, converting it to a date, and returning it as a date. Okay, so whatever the calling method does now to that date, it cannot change the high day stored inside the class. It's been cloned and copied and converted to a date. Okay, so this is good practice to do this, so that nothing is corrupting your data inside your class. If you just returned high day on its own as a local date, whatever has got that data outside the class, or that reference to that data, can change it, corrupt it. Okay, so we'll be writing more and more code like this as we go too, so that we're protecting our data. Not just returning high day, but doing a clone of it.
So we're returning a copy, not the actual reference to the data. Shadowing we talked about briefly already. That's where you got a local variable and a method having the same, name as an instance field. And we saw that up here with account number. We passed in account number. So if we set account number here and the same with nothing around it, that means the local version. And to get to the one that's at class level, you just put a this in front. This to account number. That's all shadowing is. Okay, and here we've got name, salary, and ID. Name, salary, and ID. So when you say name, it means that one. When you say salary, it means that one. When you say ID, it means that one. So put a this in front when you mean the class field. So that means these ones, this in front. And the ones without this in front means the local ones. And that's shadowing. Okay, so we overran by 5 minutes. We've still got 7 people here, which is brilliant. Are there any questions before we head off on anything? Has anyone got any questions? We covered a lot today. If you didn't quite get anything this week with static or instance, don't worry. We'll be going over it again and again and again. Okay, so just hang in there and all the cogs will click and the penny will drop soon. Don't worry. Okay. But no questions?
No, all good on my end.
Not for now.
Okay. Well, thank you, everyone. Have a nice week, and get us to practice coding. And I'll see you in next week's class. Okay. Thanks, everyone. Bye-bye.
Thank you.
Okay, thank you, sir.